All right, I'll try to make this not too long. I have to be at the airport at 9:30-ish.
Quick, ask them all the questions.
Exactly. No, there should be time for, again, interrupt me, but there should be time at the end as well. So in the second part, I want to focus a little bit what we did within Dynatrace. I've been with the company for several years. I believe a pivotal moment within our company history was 2011. Several things happened. In 2011, we mainly offered on-premise monitoring software. That means it's software that was purposely built for monitoring on-premise monolith, Java, .NET, PHP, right? And we had a 6 months update cycle. It's classical spring and fall release. What also happened in this year, our company got acquired by CompuWare, big company back then, right? Big in mainframe. So we used to be 250 people, startup mentality, all of a sudden swallowed up by a company that was like 5,000 people. And the third thing that happened, we saw an emergence of new players in the market. You mentioned earlier, Epidemics, New Relics in the market, right? And they could deliver cool new stuff much faster than we. So we set out a mission, and I believe I think we actually exceeded our goals. In 2017, what we're doing right now, we're deploying every sprint. So we've always implemented in sprints, in 2-week iterations. But back in 2011, we were not really confident of deploying that every sprint into production or to our customers. Now we are. Every sprint gets deployed. We are offering both SaaS and managed, which means we run our monitoring in the cloud, but also give our customers the chance to install Dynatrace still on-premise or in their data center. In SaaS, we actually do 500 deployment changes per day. That doesn't mean we're deploying 500 new features, but these are deployment changes, scaling up, scaling down, changing features, doing feature flagging, doing A/B testing, doing canary releases. Obviously, all this happens very automatic. The big thing and the goal that was set up by our CTO was, he said, I want the ability to deploy a code change within 1 hour across our complete fleet of installed servers in the cloud. Why? Because if something like a heartbleed is happening, we talked about security, then we have to react fast. It cannot take 2 weeks. 2 weeks is too slow, right? People always like to talk about numbers. I bring up these numbers and I'll talk about all of them later on, but the biggest change in our transformation is this number. 93% of our bugs that end up in production are proactively found by our developers and no longer by our customers opening up support tickets. The reason is because our developers are in charge of production. That means when they deploy, just as my wife, when she deploys a picture, she looks at the likes and the dislikes. Our developers, when they release a feature, they are looking at who is using it, the feature. Did something negatively change in user behavior? Do we have crashes? Do we have failure rates? What's happening? And then they react. They're looking at log files, they're looking at all the monitoring, and then automatically react in case there's a problem. How is this all possible? We started with a DevOps team. It used to be, it was 7 people strong, now it's down to 3 people. But in the beginning, what this DevOps team really did, they acted as engineers and actually product managers. Their product, as I mentioned earlier, coming back to my example with the picture story, was the pipeline. And part of that pipeline is all the different tools. So they basically were saying, we allow you to develop in Eclipse and IntelliJ, and here are some plugins that allow you to automatically then deploy into the pipeline, making a code change, and then the pipeline tests everything, deploys it into the different environments, allows you to roll out the change into a staging environment, allows you to roll out the change to a controlled number of users to do some A/B testing. So they built the pipeline and some tooling along the pipeline. And they see their pipeline as a product, and their customers are the individual application and feature teams. So if you would start within Dynatrace and you come up with a new feature and you have your team and you want to build something cool new, let's say using serverless technology, and the pipeline right now doesn't, for instance, support serverless testing, then you need to negotiate with the pipeline team and say, hey, I want to build serverless, I need to do this, how can we get this into the pipeline? Then the pipeline team figures out how to build the right tooling around it so your code changes get properly tested, analyzed, and then deployed. Okay? I have this, the part of the presentation I want to give you, I gave the whole talk at different DevOps days. The slides I will share, and FYI, on most of the slides, either on the slide or in the slide notes, I have links to either video recordings, blog posts, to more information. Just so if you want to see the whole thing that I did on, it was called From 6 Months Waterfall to 1 Hour Code Deploys. There's a great video from Toronto and also from Philadelphia. A couple of lessons, some of them might be very obvious. We didn't go from 6 months to 1 hour. It was a gradual approach. Right? We started with figuring out how can we get from 6 months to 1 month. We figured out, wow, we actually have a monolith that is 1 gigabyte big. It's a 1 gigabyte monolith to install. That's actually very painful to download all the time in an automated way, and it's also very error prone. So the first solution we actually had to do is we had to dissect the monolith into smaller components. And again, I'm not talking about microservices, because microservices is a great concept and it works great for a lot of applications, but not for everything. So we componentized. We broke up the monolith into smaller individual pieces that could be individually tested and installed and rolled out. We then implemented REST APIs to actually automate the installation process, and also figured out a way how we can actually do A/B rollouts to different customers. That was a big thing. The other thing that we had to do is we had to change the mentality, and I also have to point fingers at me. I used to be a developer that developed every day, right? And it's always great to show something on your laptop. But the works on my machine mentality didn't help us back then, and we had a lot of these developers out there. So what we actually did, in order for a developer to prove their feature to be complete, they had to demo that feature in the sprint review in our internal production environment. Which means we are building monitoring software, right? We can use monitoring software ourselves as well. We monitor our website. We monitor our Confluence, internal and external. Our JIRA that our developers use, internal and external for a support ticket. So if you are, I'm pointing at you again, if you are a developer and you want to show something at the end of the sprint, you need to make the conscious decision that that code change, if you want to show it, will end up at the end of the sprint and the automated deployment that gets deployed into our internal production environment. If you mess up, you bring down Dynatrace.com or our JIRA system. That means you and all the other developers can no longer book any tickets. Okay, but we forced developers to do so. Now here's the cool thing that happened. We broke Dynatrace.com multiple times, but we didn't bash people. Our CTO said, it is okay, we know it is painful, as long as this doesn't happen for 6 months or a year, as long as we learn from it. But it's okay to break things in the beginning. And he wanted to make it painful. So, what actually happened, those developers that broke, that checked in code that was not properly tested, that was not properly reviewed, because they cut corners, these developers started to build more tests. They went out to their peers and asked for more code reviews. They got better. They increased their push karma, if you remember from Facebook. Another thing that was very essential is, so our product that we started in 2006, so we had hundreds and thousands of features in there. And the individual product managers always thought, the greatest features ever. But the thing is, we always thought we know how our customers are using the product, until we actually asked and figured out a way how we can actually say, we know what our customers are really doing. So our traditional monitoring product back in 2011 was mainly used by our customers through our Java-rich client. So it's a Java-rich client where you analyze the data. And we had zero visibility on where do people click to, which dashboards do they open, which features do they use. So we started implementing some monitoring on that rich client application that customers instrument or implement on-premise. And then we got feedback on which particular menu items do they click, which features do they analyze. And what was very interesting, and I now have to actually point to my sales colleague, we figured out we had a lot of salespeople that were telling development, we need to have this feature in the next release because this secures the $1 million, $10 million deal, right? All of a sudden we knew that these features were never used, even though we spent a lot of time and effort to implement them to secure just one deal. So internally we have a little bad list of people that we don't listen so much anymore. But more importantly, what's interesting, this is closing the feedback loop. So our engineering teams, our feature teams know which features they're going to throw out in the next release. Right? Because why keep features around that look pretty and somebody loves within our team but nobody uses? Another thing we did, when you use our product and you have a problem as a customer, you have to open up a support ticket using JIRA. So we have a public JIRA instance, and you have to upload what we call a support archive. It's basically a zip file with all the logs. So in our product, you have a button that zips everything up, and then you upload that zip file. And our developers, that were often had to look into these files, they said, you know what, this is really boring, because I extract the file, I start here, if I see this, I go here, if I see this, then I go here, and if these three things match up, I know what the problem is. How can we automate that? Because I don't want to spend 20% of my week to do manual log analytics. So we built what we call Archie. Archie is an automatic tool that is analyzing our support archives. Okay, we built this internally first, and now we automatically hooked it up with JIRA. So every time somebody opens up a support ticket on JIRA and uploads a zip file, a webhook is fired that starts Archie, and then Archie comes up with the result. And Archie is configured through rules, and the rules are written by the developers. Because as a developer, if you build a new feature, you know which potential log messages you write that indicate a problem. So you say, in this code change, I made this log message, so I want Archie to tell me in case this log message ever appears, but automatically also reply back on the JIRA ticket what the potential problem is, so that the customer immediately knows, or the support engineer immediately knows what the first response is. Okay, so automating all of that. Another thing that was very interesting, so the first steps we made into the cloud was we took our on-premise product, that was the 1 gigabyte monolithic app, and we tried to figure out how can we run this in AWS and provide it as a SaaS service. Right? We didn't have any SaaS service, we said we just launch, we run it in SaaS. And then we provided this as a first SaaS offering, and this was 2011-ish. And what was cool with that, we could actually experiment. We could experiment and say we have, let's say, 100 people using this, and for 10 of them we update and give them a new feature, right? And what we can also do with this, we could automatically update things in case what happened here on July 4th, it was like 2 or 3 years ago. Earlier in June, come back to your point, because you're a security guy, we're using a third-party logging library. And that logging vendor told us, you're using a version of our software that has a security problem, so please update to the latest where we fix this issue. So what we did, we took the new library and rolled it out to our hundreds of EC2 instances where we ran our monolithic application on multiple tenants. Right? It was just an update of a security library. All of a sudden, we saw memory jump by 40%, and CPU jumped by 4x. Why? Because that version of the library had a different memory behavior, right? A memory leak, the way we used it. So memory went up, and because it's Java, garbage collection went up. Thankfully, because we ran on EC2, we just automatically scaled up the resources so no end user was impacted. But basically, we had to pay 4 times as much to, in our case, Amazon, to run the same feature set. Now, what the lesson learned on this is what we're now doing. Remember the example from Sofico earlier with the automated test and the looking at metrics. We're now automatically taking memory dumps before, between, and after we execute tests. And we figure out how many string objects are in the heap before, in the middle, and after tests. And how does this change from build to build? So we immediately know if a code change or an update of a library is changing the memory behavior of our apps. And even if we just see 1% more string objects on the heap, it's already suspicious, because it shouldn't be. So baking this into the CI/CD pipeline. Talking about CI/CD, back in the days we didn't have the luxury of having Hygeia. Remember that open source project I showed you earlier from Capital One with the nice visualization? We built our own visualization of visualizing builds. A key thing we had to figure out is how to improve pipeline quality, and the biggest thing was how to bring down pipeline feedback, so build feedback or build time to 10 minutes. Why was this important? Now I'm pointing to you. I have another example. If you're a developer and you check in code and it takes 4 hours or 8 hours to build, this is not actionable feedback, right? And this is actually, our build used to take 20 hours. Why? Because our monitoring software runs on all versions of Windows, Linux, Solaris, and all that stuff, and we always build everything. So one big thing we had to do is bring down build times by componentizing our code, by refactoring. Because what we wanted to do, develop our individual teams, when they check in code, we execute as many tests as we can in the first 10 minutes to give them feedback on what's happening. Because if they break the build, they should know it right away. So talking about tests, we execute a lot of tests. We're using all sorts of different tools. This is just a snapshot, but we're executing 31,000 unit integration tests, 60 hours worth of UI tests. So we're using heavily Docker to run tests in parallel. We're using Source Labs. And just as Sofico, executing these tests would just be functional pass and fail. So that's why we're additionally capturing more, I call them not actually a performance metrics, but more architectural metrics. How many JavaScript files do we have on the page? How many database statements do we make? How many string objects do we have on the heap? And then we baseline this from build to build. Thomas, he's our chief performance architect. He always gets a new build deployed into his continuous performance environment. And on every day, he basically looks at key performance metrics of his components, and he immediately gets feedback on how is an individual build doing that is running under load for a couple of hours, and then gives a thumb up or a thumb down. What we also do, similar to Sofico, we're looking at these individual metrics. We automatically baseline them, so we build this into the Dynatrace product. And if a developer makes a code change, so individual dots are individual builds, and let's say number of database statements goes up, string objects on the heap goes up, we automatically break the build. Right? Even though the tests functionally are good, we say something is wrong and we have to look at it. And what we also do, not only do we break the pipeline, but we wanted to make it very visible to our developers to actually see that something is broken. And they started ignoring the email alerts that went out. So we said we have to come up with something else. So we came up with something else. And we call it the pipeline state UFO. And what that actually is, you can see it here. This is our 2 coffee machines, obviously. Here is the door to the office where people go in and out. And we have the UFO hanging, and it is basically a little open source project that we now put on GitHub. So if you have a 3D printer, you can print it, and it's 30 LEDs, 2 lines. It has a Wi-Fi, REST-enabled interface, and we hook it up with Jenkins on the one side. So the top ring is always visualizing what is happening on Jenkins right now. Is a build running right now? And if it's done and it's fully green, it ran all the way through. Or did it break somewhere? Then it's more red. That's the top ring. So we know immediately if the build is broken. And the bottom ring, remember, our developers are also responsible for production. It visualizes, do we have any problems in production right now? Any strange user behavior? Anything abnormal going on? And the reason why we placed it strategically next to the coffee machine and next to the office door, because a lot of developers, they code, as you know, right? We code, we check in code, we walk over to the coffee machine and fill up our cup. And within 10 minutes, that maybe takes 10 minutes to walk over, fill up, chat a little bit, I want to see if the pipeline is still green. More importantly, if I walk home at the end of the day, I don't want to leave the office in case the pipeline is broken right now, because maybe it was me. So I want to double check if it's me or somebody else. Okay? And now we do not only have one UFO, every individual team has a UFO, because they have their own little pipeline, and they can also define what it means for them with production quality. And they can use monitoring. Now, talking about production quality, here's a last use case that I have for you. We use a lot of end-user monitoring, so that's also stuff we built into our product. If you're using Dynatrace to monitor your software, we actually start monitoring, and the view set this from the end user. So we know how many people are on our website, on our SaaS offering, where do they click to, are they happy or not happy, and we charge that based on performance. So a very common dashboard we look at is how many people are on the website right now over the course of the time. And also very important for a lot of us within Dynatrace is how many people will actually sign up for a new trial or log in. Right? In this case, it is sign up. So this is the time frame from April to May 1st. On May 1st, we released a new feature at Dynatrace, and our marketing team said, this is awesome, right? We want to promote the hell out of it, right? We're sending out a lot of emails. So they started pushing out emails, and what the marketing team, but also the feature team saw, hey, cool, number of users go up on the website, and they actually also sign up for the free trial. That's awesome. It was May 1st. May 2nd comes along, marketing campaign still works, the number of happy users, that's green, goes up, but also the number of not so happy users. So we charge happy and not so happy by looking at performance and interaction with the website. And what we could also observe is that conversion rate went down to the previous day. So we knew something is strange. And we looked at the monitoring data, and we actually figured out we were reaching a certain limit with a third-party vendor that we also use in that sign-up process that was causing our website or the sign-up process to get slower. So we had two options: either stop the campaign, or slow it down, or fix the problem. And then a developer jumped in and he said, I think I know how to fix the problem. Right? I'm changing something in the sign-up form. And because we have a 1 hour to code deploy pipeline, he checked in the code, deployed it, boom, crash. Or boom, crash actually meant a drop in happy user, a spike in frustrated user, drop in conversion rate. What happened? Well, the developer was using, obviously, his Chrome on his Mac. Everything worked beautifully, and ignored the fact that there's a lot of people out there with these types of laptops that are still using ancient browsers like Internet Explorer. And the change he made was a JavaScript change, and that JavaScript failed on all Windows browsers. Okay? And the cool thing is this was immediately visible here. The UFO went red, both in the marketing team because the conversion rate went down, but also of this guy for the sign-up page. So he could immediately react, fix the problem, and then everything was back to normal. So this is one of the scenarios where our developers really look at production monitoring data to figure out what type of impact they have. Now here's the problem with this. This is great if you have dedicated developers, or if you have developers that love to do this, right? Not everybody loves to do it. Not everybody knows how to draw all these conclusions. And we scaled from 1 team to 20 teams to even more teams now, and not everyone is an expert to analyze all this data. So we said we have to figure out a way how we look at the monitoring data that we have and not only tell them conversion rate goes down, but also what this really means. So now what we actually built into the product, and my colleague said it earlier perfectly, we built some machine learning in there on top of our monitoring data to figure out abnormal behavior, but also more importantly, impact. Because here's the thing, if something goes wrong and at 2 o'clock in the morning, an alarm goes off, do you want to wake up and figure out, you know what, at 2 o'clock in the morning we only had 2 people on the system? Who cares, right? They go back to sleep. But actually, that you woke up already is already a problem, right? But in case 1,000 users are impacted or 33,000 service calls, this is a big problem, right? So the first thing we actually built on top of our monitoring data is giving you the actual impact so that you can figure out is this critical or not. The other thing that we did, and this is now if you ever have a chance to use Dynatrace in an environment, we actually have built our machine learning, and based on the data we have, we actually tell you, hey, there's a problem on Dynatrace.com. The root cause is a JavaScript error rate that increased. Guess what? It only happened on desktop browsers on Windows 7, but it happens quite a lot. So this is now automatically pre-analyzed because we don't have that many engineers that can dig through all the data and have all the smartness. But we said we always find the same kind of problems, and so we built basically machine learning algorithms to figure this out. All right? What we also did, and I like this feature a lot, every time when we detect a problem, we also automatically correlate all the different things that happen in the environment. So what you see here is a snapshot, this is a screenshot from our product. So we actually show you on which machines do the Tomcats run, which Tomcats talk to each other, where's the MongoDB, where's the database, and where's the end user. So we automatically correlate all the key log messages, connection problems, JVM metrics, response time metrics, all together into a single problem ticket, as we call it. So instead of you having to log into different machines and getting the log messages and getting the data, everything is consolidated. And if you want to drill deeper to one of the problems, then you directly get there. So we wanted to make this as easy as possible. But this was not the last step we did. Accessing data and having it pre-analyzed is good, but it still means you have to get up at 2 o'clock in the morning potentially. That's not what we want to do. So here's what we actually now do. When we monitor our systems, this is one of the features that we have. It's called Smartscape. So when you install Dynatrace agents, we automatically see all your hosts and everything that runs on the host, and we monitor. We do a lot of A/B testing and feature flagging. So every time when we deploy a change from our CI into an environment, we can tell Dynatrace, hey, by the way, please be aware that I'm just deploying the blue version versus the green version here, or build 1 and 2, or feature flag A or B. When we make memory adjustments to Tomcats, we can actually tell Dynatrace, hey, I made this change on purpose. But additionally, what you can also tell Dynatrace, in case something goes wrong, I would do this and this at 2 o'clock in the morning. So we call this deployment hints, because you don't want to wake up at 2 o'clock in the morning and come up with this idea. You already know it up front. Or we can also say, hey, when we deploy something, we tell Dynatrace that this is the particular Git commit, the pull request, the JIRA ticket. So we give all this information. Why do we do this? Because we want to automate also the remediation. We actually where we want to end up is NoOps. And NoOps means nobody should get up at 2 o'clock in the morning if something went wrong that we can automatically fix actually. And so what we do now at 2 o'clock in the morning, right, when something happens, we've seen this before, we automatically start escalating. We have different teams, like to use different types of tools to get notified. But first of all, we actually figure out how severe it is based on the impact. But more importantly, we have all the chain of events, starting with the deployment and then going up. So what we also automate is our operations runbooks. But instead of just restarting a server in case something is slow, we are not much smarter. We can actually build scripts where we say, hey, Dynatrace told us after the deployment, the first thing that happened, CPU ran hot on a particular service instance. Well, the first thing I would do at 2 o'clock in the morning to mitigate the problem is maybe add some instances of that service. Maybe that solves it. Or high garbage collection on the JVM. Right? You did this. But you also told us, what would you do at 2 o'clock in the morning? Maybe revert it back or change it to another setting. So we can take this information and just execute this change automatically using Chef, Puppet, whatever you use. Or there's a problem with blue versus green, so let's switch back to green. There's a stuff that is hanging, like hung threads. Well, let's restart the service. So we are now much smarter with automating our runbooks. That's the whole idea. And if any of these changes actually mitigates the problem, what we also automatically do is update the JIRA tickets that went into that deployment. So when you come in at 8 o'clock or 9 o'clock at regular times, you see, wow, this happened at 2 o'clock in the morning. Thankfully, nobody woke me up. They added some resources for 6 hours, but obviously there's a problem, so I want to look at it, but the system healed itself, kind of. If the problem was not mitigated, then we can roll back. Then we would mark the pull request as bad, so you know at 8 o'clock they completely pulled it out. And if then obviously stuff still goes wrong, then we can still escalate and wake you up. So this is the thing we do. And the last thing I wanna show you, I think there's 2 more things actually. Breaking the, well, does this make sense? Yeah? Okay. Quickly, just to show you what else we do with monitoring. We talked about this shift left, breaking the pipeline. When we have code changes, pull request comes in, we use Jenkins internally, Jenkins builds, a Docker container falls out or whatever you use. The Docker container is probably tagged. Then we use, in our case, we are betting on Ansible. Ansible deploys this whole thing in the test environment. Our monitoring picks it up, takes all the metadata from the containers and knows, this is built November 17, this commit at this environment. Then we run our functional tests. Additional to the functional results, we look at monitoring data and then decide good to go or not. Then we deploy it into the next phase, performance environment, multiple versions of that container. Remember that example from earlier, we can compare it automatically to the previous build. If it's good or if it's bad, we stop the pipeline. If it's good, the pipeline goes on. And then we deploy it into production. And then we can do a blue deployment next to a green deployment. And then we start monitoring blue versus green. And in case something goes wrong at 2 o'clock in the morning, we switch back. All automatically. All right? 2 more examples. sorry for that, it's taking a while now, but quickly, performance is self-service. Remember the stuff that my friend Mark Tomlins at PayPal is doing? So the same thing here. Got a pull request, you have a developer creating a JIRA ticket, we implemented the same thing, is building something, Docker container falls out, we deploy it into an environment, we run some JMeter scripts, and then we push the results back to JMeter. And in case the developer sees something is wrong in there, direct click either to the JMeter detailed results or to the monitoring data. And to close the feedback loop completely, and this is coming back to what Facebook is doing, we're using JIRA internally for our requirements management and everything we basically do. So if we have a requirement, like, hey, we want to have a new one-click purchase checkout option, hopefully with some success criteria, right? How fast should it be? How many people should use it? We can also label it, how the monitoring tool actually monitors that feature, and then we can automatically pull in live monitoring data. So the product manager or the business analyst that comes up with that feature doesn't have to learn yet another monitoring tool. We just pull the data in from the monitoring tool so that he sees how is the feature behaving over time, over the last couple of weeks. Are people using it, yes or no? What's the response time? And then they take this data and say, crappy feature, nobody uses it. Or, it's not too bad, but it's too slow, let's optimize it. And now it's all evidence-based decisions now. So we do a lot, we do all this, and what I like the most, and this is really my last statement, and I like this the best, this is what our developers say. We are proud of our features, because no longer are we getting only feedback from customers if they open up a support ticket and they complain about bad quality, but now we immediately see what impact we have. And this comes back to the shared responsibility in DevOps. We come up with an idea, we push it through the pipeline, we test it out. In case it's not good, we take it away, but if it's good, we are really happy, right? And we support our business. So that's it. Hopefully that gave you some insights into some of the stories, what we do, how we do it internally, and yeah, questions?
How does it determine that there's a JavaScript error? Is that just from looking at logs? Or?
No, what we do, shall I quickly show the product so that people know what we're doing? Because right now it's just PowerPoint magic, I would say. Let me quickly move over. And I think this is true. I mean, what I'm showing you is, I think is a lot of functionality that hopefully most modern monitoring tools have. Am I seeing the right screen? Yeah. So if I go to Is it wrong screen? Let me just share the screen now. All right. So what I have, the way this works is you install Dynatrace on the host. So that means in my case, the way you would install it, click on start installation, then you are picking your operating system. If it's Linux, you download that script. You can validate that the download is legit, and then you install it. So you would then automate all of this with your Puppet Chef Ansible script or code deploy. Once you are installed, what we actually do for you, and you've seen this before, is we really do full stack monitoring. So in my case, I have 37 different hosts where I have an agent installed, and I can zoom in here a little bit. So I have some Linux machines and some Windows machines. What our agent automatically does, it automatically monitors every single network connection, so TCP/IP connection of every process, so it automatically knows the dependencies to other machines. This is the blue lines. I call this the horizontal dependency map. But more importantly, is that this agent that you install on a host also automatically sees every single process. And if it is a Java, a JVM, a CLR, a PHP, Node.js, Go, we automatically instrument that app. So when the JVM starts up in that process generation, we are using a command line option of Java to hook our Java agent in, the do bytecode instrumentation. The same is true for other technologies. Now, if it is a web server or an app server that delivers HTML back to your browser, we automatically intercept that HTML and add a little script tag to it. So we automatically add a JavaScript file on that page. We also give you a manual option if you don't like that. Or if you're, for instance, using a SaaS offering, let's say Salesforce.com or Office 365, then you can add this JavaScript tag by modifying your templates, right? So, and what we really do then is we start monitoring every end user. And actually, it's funny enough, I have a couple of my environments monitored here. So this is our demo environment. And what I'm seeing is, I'm seeing how many users are on the system. It seems something is actually problematic right now. You can see that we automatically baseline response times. We can see that there's a slowness happening right now. And what Dynatrace automatically tells me is what we saw earlier. What we really do is we open up this problem ticket. How many users are impacted? What's the application impact? It's across all geos, all browsers, all OSs, all user actions, so all features. It's a global problem. It seems we had some network issues on these machines. And what they can also do, this is what I showed you earlier. This is where we kind of combine all the data we collect. And this is what I love about this. This is kind of like a time-lapse view. How can I move this away? So the problem has been going on for more than half an hour. But I can hit the replay button. This is now a time-lapse view that shows me on which components the problem started and how it evolved through the system. Now, this is not the complete system, but only those components that actually support that app that is currently experiencing an issue. Right? And so what do we factor in here? Response time problem, network problems. We also do automatic log monitoring. And from an end user perspective, I'll show you what data we have here. We really have every single end user. And that's true for real users in production, but also in testing. And I can say, let's say, for a web application, browser family, IE. I love my IE still. Some people have to love it, right? So you can see here the list of users that came in the last 2 hours. We can capture usernames. So if somebody calls in, or you use a test username in your testing scripts, you can pick it out. And then I can see all the different browser sessions they had open. So we are tracking every session. I can click on a session. I can see more information about what type of browser they used, where they are from Korea, IP address, ISP, and I see every single action. This page, this page, this page. And then I can even pick individual pages. And then our JavaScript file also captures browser performance data using W3C resource and navigation timings. So a high-level overview, but we also give you the full waterfall diagram. Okay, for every single click of every single user. And that is great for analyzing why does this user behave differently than all the other users that come from different geos, right? What is wrong with this test script versus the one we ran yesterday, because you can also compare it. And then what's also nice, if you have the server-side instrumented, you can see here there's a request to orange.jsf. I can actually go in and say view pure path. So what we do server-side, we actually capture on the server, on your infrastructure, every single request. And hopefully this is a good one. It's not that exciting, but this comes in on Apache. So we have all the details on all the request parameters that come in, headers, and then it goes off to my JVM. And then I can also click on code level information. So this is all automatically there. I mean, this is technology that, again, most monitoring vendors used bytecode instrumentation. What we just do, we capture much more information. Not only the app, but also the complete infrastructure. And then we can run our machine learning on top of it. And I think, I don't want to make this more commercial as this already is, but if you want to try it, go to Dynatrace.com, sign up. We provide this as SaaS, but also managed. So if you want to install it locally in your environment, then you can also do it if you don't want to send data to somebody else. Any other questions to some of the other DevOps stuff? Yeah?
You mentioned when running unit tests that you're measuring memory usage, what's on the heap and such. That's something I'm less knowledgeable about, so my question is actually, can you recommend a place to where I can look up, what's actually the right way to do this, for example, to run the garbage collector first or not?
So the question, if I repeat it, so you said you don't have that much experience on memory diagnostics and unit testing. What are the best practices, garbage collection before, after? There's different, if you go to Dynatrace.com, we actually have a free Java book online that talks about Java memory diagnostics. And there's different use cases. I think both of them are valid. The reason why you would kick in the garbage collector automatically is because you want to figure out how many objects are still on the heap. But the reason why you would not run a garbage collector is because you want to figure out object churn rate, right? How many objects are constantly getting garbage collected and not. So that's why what we actually do, we run certain tests multiple times and doing exactly that. Either hitting the garbage collector to figure out is there anything leaking or what's the object churn rate. And then also I think we have a blog post from one of our guys who built the test automation framework. He talks a lot about how he's actually warming up the test environment, and that for unit tests, for instance, we typically don't look at things like response time because it doesn't make sense for unit tests that execute in like 2 milliseconds, but you more look at architectural metrics, like how many log statements are created, how often do you call a certain API. These are more countable measures that are not impacted by a slow Docker container or something like that. So for unit tests, we also differentiate between unit tests and what we call performance unit tests. Performance unit tests are tests that are actually testing a performance aspect of a certain feature, and this means typically these tests run for at least a couple of seconds up to several minutes. And then it also makes more sense to look at performance metrics like response time and things like that. If you are interested on the Dynatrace blog, we have a series that is called Dynatrace on Dynatrace. So kind of how do we use Dynatrace internally in our environment, so that should give you some idea.
Thank you.
Is there a list of metrics for the pipeline, like a common lexicon of, at this point, look at these, at this other point, look at those?
So the question is there a list of metrics for individual stages of the pipeline to look at? I'm sure every company is doing it differently a little bit, I guess, right?
That's why I wondered.
Yeah. I think what you want to do is you want to actually start with what is the end game. The end game is you want to deliver features with a certain velocity, right? So how often do you actually deploy? And then what you also want to make sure is that the deployments are not bad. So user impact, user behavior afterwards, failure rate and things like this. And then if you see the impact on the end, then you try to figure out, okay, what can we do to make these numbers stable or better? Where do we need to start? Hey, most of our problems that we've seen the last week or month are all related to bad web performance. So we want to build in more checks up front, so maybe more functional tests that do these tests. Or we've seen code changes that are constantly messing with the database. So we want to write more integration tests, more functional tests, more unit tests on the database layer. And then monitor things like database behavior change or database access behavior change. So I think, instead of saying, so for instance, what I don't like at all is say we need to have 90% code coverage in our tests, right? Because if you're covering the wrong type of code, who cares, right? So, and I believe code coverage comes on its own once you actually put developers in the driving seat of being responsible for production. Because then they say in the beginning, that's cool, we deployed to production. And then they figure out, shit, we broke it again, so what can we do? Oh, let's maybe write some tests. Oh, okay. So then it becomes a balancing act, but instead of forcing them to reach an artificial number in pre-prod, in testing, you are motivating them to just build the right tests to make sure the end result has the right quality. Right? And eventually you will find your magic number, what that really means.
Anything else? Okay, great. Oh,
Yeah.
So it sounds like collecting more data than some of your competitors. You do it all. How long do you keep it for a period of time? And how much data is it produced?
So we produce a lot of data, and I think it's not only data that we collect, and then again, I don't want to get spiritual about it, but I think there's a difference between data and information. Right? So I think a key thing, what we try to solve, is understanding the dependencies between different metrics. because I can look at garbage collection and at CPU, and if I don't know how they're correlated and related, it doesn't make, you know, it's just data. That's why we are collecting all this dependency information, and then we are basically running our baselines and our anomaly detection. But to your question, how long do we keep data? There's two types of data that we collect and keep. The one is time series based data. So in the most granular state, we are keeping 10 seconds resolution of response time, failure rate, and all this stuff. But then we are aggregating it to a minute, to an hour, to a day. So we age data, the older it gets, but basically we keep data, time series data forever, because you always want to compare how did we do last holiday shopping season versus this year and versus 5 years ago, right? But then the code level information down to every single method level, this doesn't make sense, not always make sense to keep around forever, right? So there the data retention is depending on how much storage you dedicate to Dynatrace. It also depends if you run it in SaaS, where we have to provide the storage, or whether you run it on premise and then you can put whatever storage, typically a couple of days. But then you can also mark certain periods of time where you say, I want to keep this data because this is a representative day or representative hour of a very critical time, and I want to look at this data later on in all the details. So you can also do that. Yeah, we actually have one of our architects, he did a session with AWS, which is called, I think it's called My AWS Architecture. It's on YouTube. So AWS does these interviews with companies that build their architectures on AWS. And Andreas Grabner, he actually did a session. So I think it's called My Architecture on AWS. And he explains also what type of storage systems we use for different things. We use Elasticsearch on the one side, we use Cassandra, we use file storage, because different data needs to also be stored in different ways for different use cases. Okay. All right, time for the raffle?
Yes.